there are 3 statistical intervals that are useful to know and useful to be able to distinguish between them and know when to use which. So we're talking about confidence intervals, prediction intervals, and tolerance intervals. Now, common for the 3 is that the width of them, they're all determined by mainly 3 things. The standard deviation of your data, the noise of your data, the width of your data, your current sample size, are you taking 5, 30, has a very big impact on the width. And finally, the alpha level, because they all talk about some kind of certainty or confidence within, because you will say in all 3 of them that you are 100% minus your alpha, which would normally and often be set to 5% or 0.05, certain within a range. So let's start off with confidence intervals. So confidence intervals is on an estimate. So it might be the estimated mean, it might be the estimated proportion, standard deviation, it could be almost anything. There's confidence intervals on a lot of things. But what's important to remember is that it's on estimates. So let's go with the idea of an estimated mean. Now, if you took another sample, you know that mean might slightly differ. So you could wonder, well, where's the true mean of the population that you would know if you sampled everything? But since that is often very inconvenient, we have this width. We would say, okay, within this width, I'm 100% minus alpha confident that my true mean is. It's the most narrow of the 3, and I will come back to why. So that's confidence intervals. Prediction intervals is on future single observations. Now, so you determine how many future observations, and normally we go with just 1. So what you say is, I want to be 100% minus alpha confident that my n future value or my next future value is within this band. So naturally that will become wider than your confidence intervals. Now, why is that? Well, it's because it's on individual values. So let's say that you had a mean and you estimated it and it falls right on your upper band of your confidence interval, or confidence, which it may, because that's what you just said. So in order to estimate that mean, you had some data, right? And your data of individual values. And if you want to be able to estimate just one of those points, naturally your prediction intervals becomes wider. It's a very cool interval, and it is actually often what we try to say when we make predictive modeling, because we're actually not trying to be okay on average. We want to be okay on future values. But even more cool is the tolerance intervals. And it speaks for a proportion. So you set some kind of p, let's say 99, and you say, I want to be 100% minus alpha confident that 99% of my future production is going to be within this range. So, as you can hear, it's even wider. So it's the widest of the 3 because it doesn't cover the estimate, it just doesn't cover just the next single value. It covers 99% of future values. So if you have a spec, let's say you have a lower spec limit, and you have an upper spec limit, it's super cool to be able to say, I'm 99% confident, or I'm 100% minus alpha, confident that 99% of my future production is going to be within my specification limits. Now I kind of ran out of room here because you can see I'm actually kind of close to the upper spec, but still it's a cool thing to say. There's only 1% that will fall outside this band. Yeah, so those are the 3 main statistical intervals. I hope you found it useful. If there's any questions, don't hesitate to put them in the comments, and thanks for watching, and catch you in the next one. Bye.